All right, let's get right into it. If you've ever tried to build anything in Florida, you know the biggest challenge isn't the sun or the storms, it's the ground itself. Today, we're going to unpack a pretty revolutionary new science that's turning Florida's #1 problem into its greatest asset. We're talking about creating roads and foundations from, get this, sand and leftover farm scraps.
And it all starts with this stuff right here, sugar sand. It's all over Central Florida. And yeah, it looks pretty on the beach, but for a builder, it's an absolute nightmare. It's super fine, it's loose, and it just will not stay put. For decades, this one material has basically controlled how much it costs and how hard it is to build anything in the state.
So that brings us to the big question we're tackling. And I know it sounds a little out there. Can you really build a solid, permanent road using the waste from Florida's most famous crops? Well, the answer is a big yes, and it's all happening way faster than anyone thought was possible.
To really get what a game changer this new tech is, we first have to dig into the problem itself. We got to understand the ground beneath our feet to see why this sugar sand has been such a massive headache for engineers for so long.
So the technical term for it is non-cohesive, which is just a fancy way of saying the little sand grains have absolutely zero interest in sticking together. So what happens? You put weight on it, like a car or a house, and it just moves. And when that famous Florida rain shows up, it washes right away. This means you can't just build on it. You have to spend a fortune digging it all up and swapping it out for something that's actually stable.
But what if you didn't have to replace it? What if the fix was a super concentrated liquid that showed up in a simple 55-gallon drum, and it could transform the sand right where it sits? I know, it sounds like science fiction, but this is the new reality of soil stabilization.
So how on earth is this even possible? Well, the secret ingredient isn't really in the drum. It's in the cloud. We're talking about artificial intelligence. It's taking what used to be a lifetime of messy lab work and crunching it down into just a matter of days to find the perfect chemical recipes for this age-old problem.
And this is a huge leap forward. I mean, the old way was just slow, expensive trial and error. You'd be literally mixing bucket after bucket of chemicals, just hoping you stumble onto something that works. The new way? It uses AI to run thousands of digital simulations, predicting how different molecules will behave before anyone even puts on a lab coat. It's a total paradigm shift.
So how does it actually work? Well, think of AI as a super smart chef. First, a generative AI comes up with millions of potential recipes for new, stable molecules. Then, powerful quantum simulations act like a taste test, predicting exactly how those new molecules would bond with the sand, right down to the atomic level. And this lets scientists zero in on the perfect recipe that, and this is the key part, uses local waste products like citrus peels and sugarcane fiber. Okay, so let's pop the top on that drum and see what's actually inside. The absolute genius of this is that the solution isn't some weird, expensive chemical shipped from halfway across the world. Nope, it's a high-tech cocktail made from the leftovers of Florida's own huge farming industry. And this right here is the magic ratio. You're not replacing the sand, you're upgrading it. A full 95% of the final road base is the original sugar sand that was already there. Only 5% is this concentrated biopolymer formula that kicks off the whole transformation, and that's exactly what makes it so affordable and easy to do.
Now, to make this super simple, let's think about it like baking a cake. Maybe a Florida fruit cake. The local sand is your flour. It's the main ingredient, the bulk of it all. The bioliquid from the drum, that's your syrup. It's the sticky binder that's going to hold everything together. And finally, you've got a third ingredient, ash, which acts like baking powder. It's the chemical kickstarter that makes the whole thing harden up into a solid slab.
So let's look a little closer at that syrup. You've got pectin from orange peels, which is basically a natural glue, but the AI-designed formulas figured out how to make it waterproof. Then there's lignin from sugarcane, another sticky plant byproduct that's been tweaked on the molecular level to create this kind of organic concrete reaction with the sand. And crucially, it has something called bio-surfactants. Just think of them as a wetting agent that helps the whole mixture soak deep into the ground, making sure you get a really strong bond.
Now for the baking powder, the ash that gives the whole thing its backbone. It's usually a mix of traditional coal fly ash and the real Florida game changer, sugarcane bagasse ash, or SCBA. The AI models discovered that the microscopic shape of this sugarcane ash is incredibly jagged, and that unique shape makes it almost perfect for physically locking those tiny grains of sugar sand together into a solid, unmovable block.
Okay, so we've got the science, we've got the ingredients, but how do you actually go from a drum of liquid and a pile of ash to a road you can drive on? The answer is a process that's basically a factory on wheels that rolls across the land.
It's pretty cool. It works like this. First, a spreader truck lays down this perfect, even layer of ash. Right behind it, here comes the star of the show, the reclaimer. It's this big machine that churns up the top foot of sand and ash, and at the exact same time, it injects the bioliquid right into the mix. Then a grater comes along and smooths it all out. And finally, a heavy vibratory roller compacts it all down, which triggers the final chemical reaction and turns it into synthetic stone. Now, this all sounds amazing, right? But the real question is, when are we actually going to see this stuff? So let's take a look at the timeline for this technology to go from some experimental test roads to maybe your own driveway. So, the plan is to roll this out in phases. In the next 1 to 3 years, you should start seeing it become available for private roads and driveways. Then, in about 3 to 5 years, you can expect to see things like Florida bricks made from this sand and waste mix. And then, maybe within a decade, after a whole lot more testing, this could become the new standard for public highways.
For anyone in land development, this is a really big deal. It solves what's known as the paper street problem. That's where land is all plotted out on a map, but you can't get to it because building a road is just too expensive. By getting rid of the need to haul in tons of heavy lime rock, that's the crushed stone normally used for road bases, this tech slashes costs and the carbon footprint of construction. It makes building on those remote, sandy lots totally possible for the very first time.
I just love this quote from one of the sources because it nails the idea perfectly. You're not importing a road, you're using local materials, both the sand and the agricultural waste, to essentially grow your road base right where you stand. It's just a totally different way of thinking about how we build things.
And, that leaves us with one last, really interesting question to chew on. If Florida can build its future roads from orange peels and sugarcane, what other local waste products around the world are just sitting there, waiting for an AI to unlock their hidden potential? I mean, what could your city be built from?